Presenting physics tutorials on Frictional force
by Alex, Michael, and Christopher. Alright, young buckies. I will describe to you physical force. Now, before you even get into physical force, you have to go into the force of gravity of this object. Now, the force of gravity works perpendicular to the surface of the Earth. But the normal force acts in perpendicular to the surface of which the object sits. And since those two don't really line up, you have to separate this into different vectors. And the easiest way to do that is to use a right triangle. And you should, you should learn this in geometry. Anyway, and we'll make this angle 30 degrees. Anyway, we'll make this because this angle is adjacent to this. This is going to be cosine, and since this is going down, this is going to be our mg cosine of theta of 30. Because this angle and this angle are the exact same thing, which makes this angle in the force of gravity in the x direction mg sine theta. Now, if this is not moving in the y direction, this is not going up, down, this is not going down, that means the normal force is equal to this gravitational force times cosine theta. And I'm going to solve that for you. mg, we made this mass 20 degrees times gravity, which is 9.8, is going to equal to 196 newtons. Now to get this one, you have to do mg. You got to take this and multiply this times cosine of theta, which is 96 times cosine of theta, with cosine of 30 degrees equal. Let me get the.
You said 196.
Which equals 98.
Cosine.
Oh, no, wait, this one's 98. But this one's not. Sorry about that. This one's 98. What's this one?
That's 170.
This one equals 170. That means this normal force is approximately 170, exact 169.7 newtons, which makes this force in the force of this is the force of gravity in the y direction, and then this is all in proportion to the surface. We make this y and this x, which makes this equal. Since they're equal, they cancel each other out, means it will not move. But
you forgot to also include that this should be right there. Your frictional force, sorry about that. And to conclude that, to prove that the box is not going anywhere, we say that the mg sine in this direction and the frictional force in that direction are equal, which allows the box to stay where it is. Now, unless we didn't have a frictional force, then the box would be going in the opposite direction, sliding down, which will mean that it has a frictional force.
Okay. Actually, if this was frictionless, it would be accelerating this way.
Yeah.
But to find the acceleration, you'd have to do acceleration equals force. Yeah, force
times mass.
And
divided by mass.
Divided by mass. We get that from the equation F equals m times a. Now, luckily, we have our force in this direction, which equals 98. So it will 98 minus your mass, which would be 20. And when we do this,
98 divided by 20,
which equals 4.9 meters per second squared. I mean, this was frictionless. This was frictionless. It will be accelerating down the slope at 4.9 meters per squared.
Meters per second.
Meter per second squared. Oops, sorry about that. Meter per second squared. Thus is the stagnant object. This one's presentation brought to you by Christopher Blake Gorman. Our friend Alex.
I still don't get this, man. I still don't get this.
Well, looks like you'll be coming to next year, young Bucky.
Oh, man. Dang.
Give Alex Hitchcock, Alex Hicks, background applause.